Welcome to my YouTube channel T.NATH Physics class. Today I'll discuss 3-mark question, remaining 3-mark question from CBSE Class 12 Physics paper 2020 set 2. Let's start. First question. Two cells of EMF E1 and E2 have their internal resistance R1 and R2 respectively. Deduce an expression for the equivalent EMF and internal resistance of their parallel combination when connected across an external resistance capital R. Assume that two cells are supporting each other. Okay. Part B. In case the two cells are identical, each of EMF E equal to 5 volt and internal resistance R equal to 2 ohm, calculate the voltage across the external resistance R equal to 10 ohm. So these are the question. Okay. So as per question, we draw this diagram and the equivalent circuit is here. Okay. When two cells are combined, it will become equivalent EMF will be E equivalent and equivalent resistance Req we consider. In this circuit, I1 and I2 are the current flows through E1 and E2. Therefore, total current must be I1 plus I2. Okay. So our aim is that we have to find out the expression of voltage for this part, and then with this voltage expression we compare the voltage expression of this. As you know, voltage is always conserved. Here the voltage and here the voltage will be have the same value. From this we find out the equivalent EMF. Okay, let's proceed here. The term, as you know, terminal voltage is always less than the voltage drop across internal resistance. Then V for first cell, V equal to U1 minus IR1. Then we find out the value of I1, that is E1 minus V by R1. Similarly, for the second cell, I2 equal to E2 minus V divided by R2. Okay. Putting the value of I1, I2 in equation 1, putting the value of I1 and I2 in equation 1, we have I equal to E1 minus B divided by R1 plus E2 minus B by R2. Then calculation, here is the calculation, and we find out V equal to R2 E1 plus R1 E2 divided by R1 plus R2 minus I R1 R2 divided by R1 plus R2. So now for equivalent circuit, what is the expression of voltage? That is V equal to E equivalent minus whatever the voltage drop across the equivalent internal resistance. So just you compare these two equations 4 and 5. How much you got? In place of E equivalent, how much you got? That is R2 E1 plus R1 E2 divided by R1 plus R2. And in place of R equivalent, we found R1 R2 divided by R1 plus R2. So in case of parallel combination of cell, internal resistance always follow the parallel combination of resistance. Okay. Now second part. What is the second part? That is question number P. Okay. So second part. So as per question, E equal to 5 volt internal resistance for each cell is 2 ohm and external resistance R equal to 10 ohm. And how many cells are there? Two identical cells. When n number of cells are connected in parallel to an external resistance, then total current should be equal to I equal to NE divided by small r plus n capital R. Here small r is the internal resistance and capital R is the external resistance. Insert the value of N, E, small r, capital R. How much you got? 2 into 5, because value of n is 2. Okay, and value of E is 5, internal resistance is 2, then n equal to 2 and external resistance 10. So how much you got? 10 by 22. Now as per the question, we have to find out the voltage drop across external resistance capital R. So what is the formula? V equal to IR. Value of I is how much you got? 10 by 22. R is 10. 50 by 11. After calculation, how much you got? That is V equal to 4.5 volt. 4.54 volt. Okay. Question number 33. Write an expression for magnetic moment associated with current I carrying a circular coil of radius small r having n turns. Consider the above mentioned coil placed in YZ plane with its center at the origin. Derive expression for the value of magnetic field due to its at point x 0 0. Okay, y-axis value is 0, z-axis value is 0. So it means that we have to find out the magnetic field along x-axis. Now, what is the formula of magnetic moment for one turn? That is m equal to Ia. Since there is n number of turns, so m equal to Nia, where A is the area of the coil. So therefore, m equal to Ni, area of the coil is pi r square. Okay. So here is the diagram. So magnetic field along x-axis x, and this is the position we consider it is A. We have to find out the magnetic field at P. So as per B.Ed law, we use, that is, we consider small part dB. Okay. For this small part, the magnetic field is dB, and how much you got? dB equal to mu naught by 4 pi I dl sin theta by distance is how much? A. That's why S square. Okay. Where theta is the angle between small part of this coil length, small part of the coil length, and this line joining. It will be 90. Okay. Therefore, insert the value of sin theta 90 is 1. Then dB equal to mu naught by 4 pi I dl by S square. So if for this small part, magnetic field is along PS direction. If you resolve it, we'll get two components, dB cos phi and dB sin phi. And for this small n, for this part, again we get two components, dB cos phi and dB sin phi. So from this diagram, it is very much clear, dB cos phi component will be cancelled out. So entire magnetic field is given by dB sin phi component. So for whole coil, the magnetic field we have to integrate over dB sin phi. Okay. So therefore B equal to integration mu naught by 4 pi I dl by S square sin phi. So mu naught by 4 pi I S square sin phi, all are constant, take it out. We have to integrate over dl. Now what is the value of sin phi? R by root over R square plus S square equal to R by R square plus S square to the power half. S square is, just use the Pythagoras formula, S square equal to R square plus S square, and integration over this dl, that will give you the total circumference of the coil, that is R of radius, circumference of the coil of radius R equal to 2 pi r. So insert all this value and calculate, and we found b equal to mu naught by 4 pi 2 pi r square I by r square plus s square to the power 3 by 2. So since they asked for n term, for one term if the value of mathematical is this much, then for n term you should multiply with this value with by n. Okay, so how much you got? B equal to mu naught by 4 pi n into 2 pi r square I divided by r square plus s square to the power 3 by 2. Optional question: define current sensitivity of a galvanometer, write its expression. Okay, next part B. A galvanometer has resistance G, shows full scale deflection for current Ig. How it can be converted into ammeter to measure the current up to I naught? What is the effective resistance of this ammeter? Okay, current sensitivity means deflection in the galvanometer, deflection in the ammeter divided by flow of current, that is theta by I. Now from galvanometer expression, theta is INBA by C, where I is the current, N is the number of turns, B is the multiple, A is the area of the coil, C is the resisting torque per unit twist. So insert the value of theta and calculate. We got current sensitivity as MBA by C. Okay, next part B. So how can you convert galvanometer into ammeter? Just you connect a very small resistance, that is called shunt resistance, with in parallel with galvanometer, then it convert into ammeter. So from this circuit, I naught must be equal to Ig plus Is. Again, galvanometer resistance and shunt resistance are parallel, so voltage across galvanometer resistance and shunt resistance must be equal to each other, that is Ig into G equal to Is into S. Then Is equal to Ig into G divided by S, where G is the resistance of galvanometer. So just putting the value of Is in equation 1, then I naught equal to Ig plus Ig into capital G divided by S. So our aim is that we have to find out the value of S. So just here calculation will be there. See the calculation: I naught equal to Ig plus Ig into G divided by S. Okay, I naught minus Ig, then S equal to Ig into G divided by I naught minus Ig. So here galvanometer resistance and shunt resistance are parallel to each other, therefore equivalent resistance must be equal to Gs divided by G plus S, where G is the galvanometer resistance and S is the shunt resistance. Okay, next part, next question: the nucleus mass number 235, atomic number 92. Why? Okay, initial at rest, decay into another element X, whose mass number is 231 and atomic number is 90, by emitting an alpha particle. The reaction is given below. Okay, the binding energy per nucleon of parent nucleus, the daughter nucleus and alpha particle are given as 7.8 mega electron volt, 7.835 mega electron volt and 7.07 mega electron volt respectively. Assume the daughter nucleus to be formed in the unexcited state and neglecting its share in energy of the reaction. Find the speed of the emitted alpha particle. So mass of the alpha particle is given. So ultimately we have to aim that we have to find out the velocity, with which velocity a particle is moving. So for that one, first of all, you have to find out the energy release. That energy will be provide us kinetic energy, and with that kinetic energy, the particle will be moving. So from this kinetic energy, you find out the value of velocity. Okay. So here, energy release Q equal to binding energy of X helium minus planet nucleus. So for per nuclei, binding energy is 7.835. Then to release, just you multiply it with mass number. Same process will be here. And after calculation, how much you got? The value of Q is 8.26 into 10 to the power minus 13 joule. The energy used by alpha particle as kinetic energy. Therefore, this kinetic energy should be equal to value of Q. And kinetic energy is half mv square equal to Q. P equal to root over 2 into Q by m. Put the value of Q, m, mass of the alpha particle, and after calculation, how much you got? The velocity of alpha particle is 1.57 into 10 to the power 7 meter per second. So this much for today. So I'll discuss some more questions from this exam in my next class. Stay safe, stay at home. Thank you for watching my video.